We know that the triangle with two congruent sides is called an isosceles triangle. Greek meaning isosceles, meaning having two equal sides. Now, let us study an important theorem about isosceles triangle. Isosceles triangle theorem. If two sides of a triangle are congruent, the angles opposite to them are also congruent, also called as the base angles. Now given, in triangle PQR, side PQ is congruent to side PR. To prove, angle PQR is congruent to angle PRQ. Construction. Draw the angle bisector of angle QPR in triangle PQR. It meets side QR at point M. Proof. In triangle PQM and triangle PRM, segment PQ is congruent to segment PR. This is given. Angle QPM is congruent to angle RPM by construction. Segment PM is congruent to segment PM, its common side. Therefore, triangle PQM is congruent to triangle PRM, side angle side test. Angle PQM is congruent to angle PRM, corresponding angles of two congruent triangles. Angle PQR is congruent to angle PRQ. Reason: point M lies between point Q and point R. Let us study an important property of 30 degree, 60 degree, 90 degree triangle. Theorem: if the acute angles of a right angled triangle are 30 degree and 60 degree, the side opposite to the angle of 30 degrees is half the hypotenuse and side opposite to 60 degree angle is square root 3 upon 2 of the hypotenuse. Let us prove this theorem. Given, in triangle PQR, angle Q is 90 degree, angle R 30 degree, angle P 60 degree. To prove, PQ is equal to 1 upon 2 PR. Construction. Extend side PQ and mark point S on it in such a way that PQ is equal to QS. Join points S and R. Proof. In these triangles, triangle PQR and triangle SQR, segment PQ is congruent to segment SQ. This is by construction. Angle PQR is congruent to angle SQR. Both are right angles. Segment QR is congruent to segment QR. It's the common side. Therefore, triangle PQR is congruent to triangle SQR, side angle side test. Angle QPR is congruent to angle QSR. These are the corresponding angles of congruent triangles. In triangle PQR, measure angle QPR is 60 degree. Therefore, in triangle SQR, measure angle QSR is equal to 60 degree. In triangle PSR, measure angle PSR is equal to measure angle SPR is equal to measure angle SRP is equal to 60 degree. Sum of interior angles of a triangle is 180 degree. Triangle PSR is an equilateral triangle. Therefore, PR is equal to PS is equal to SR, corollary of converse of isosceles triangle theorem. We have PQ is equal to 1 upon 2 PS. This is by construction. PQ is equal to 1 upon 2 PR. Therefore, PS is equal to PR, statement 1. In the right angled triangle, triangle PQR, PQ square plus QR square is equal to PR square by Pythagoras theorem. 1 upon 2 PR square plus QR square is equal to PR square. This is from the equation 1. 1 upon 4 PR square plus QR square is equal to PR square. Therefore, QR square is equal to PR square minus 1 upon 4 PR square. QR square is equal to 3 upon 4 PR square. Therefore, QR is equal to square root 3 upon 2 PR. Now we will study the theorem about 45 degree, 45 degree, 90 degree triangle. Theorem of 45, 45, 90 degree triangle. If the angles of a right angled triangle are 45 degree, 45 degree, 90 degree, each of the perpendicular sides is 1 upon square root 2 into the diagonal. Observe this figure. Given in triangle LMN, measure angle LMN 90 degree, measure angle LNM 45 degree, measure angle MLN 45 degree. To prove LM is equal to MN is equal to 1 upon square root 2 into LN. In triangle LMN, measure angle M 90 degree, measure angle L is equal to measure angle N is equal to 45 degree. Therefore, LM is equal to MN, converse of isosceles triangle theorem. In triangle LMN, LM square plus MN square is equal to LN square by Pythagoras theorem. Therefore, LM square plus LM square is equal to LN square. Therefore, LM is equal to MN. Therefore, 2 times LM square is equal to LN square. Therefore, LM square is equal to 1 upon 2 LN square, and therefore LM is equal to 1 upon square root 2 LN. Therefore, LM is equal to MN is equal to 1 upon square root 2 LN. Let's solve a few examples now. Observe the following diagram. In triangle PRS, PQ is perpendicular to RS. Angle R 45 degrees, QS is 3, PR is 4 square root 2. Find the length of PQ and RS. Solution. PQ is perpendicular to RS. Measure angle PQR is 90 degrees. Triangle PQR is right angled triangle. Measure angle PRQ is equal to 45 degree. Therefore, measure angle QPR is equal to 45 degree. Therefore, QR is equal to PQ is equal to 1 upon square root 2 into PR. 45 degree, 90 degree theorem. QR is equal to PQ is equal to 1 upon square root 2 into 4 square root 2 is equal to 4. RS is equal to QR plus QS. Reason? Point Q lies between point R and point S. RS is equal to 4 plus 3 is equal to 7. Therefore, PQ is equal to 4 and RS is equal to 7. Observe the following diagram. In triangle GST, GS is equal to GT. Angle GTD is equal to 125 degrees. Find out measure angle SGT. Solution. Angle GTD is an exterior angle of triangle GST. This is from the diagram. Measure angle GTS plus measure angle GTD is equal to 180 degrees because angles in linear pair. Therefore, measure angle GTS plus 125 degrees is equal to 180 degree. Therefore, measure angle GTS is equal to 180 minus 125 is equal to 55 degree. Triangle GST is an isosceles triangle given GS is equal to GT. Measure angle GST is equal to measure angle GTS by isosceles triangle theorem. Therefore, measure angle GST is equal to measure angle GTS is equal to 55 degree. In triangle GST, measure angle SGT plus measure angle GTS plus measure angle GST is equal to 180 degree, sum of interior angles of a triangle. Therefore, measure angle SGT is equal to 70 degree. In triangle SKY, measure angle K is equal to 90 degree, measure angle Y is equal to 30 degree, SK is equal to 3.5 centimeters, then find KY and SY. Solution: in triangle SKY, measure angle K is 90 degree, measure angle Y is 30 degree, SK is 3.5 centimeter. This is given. Therefore, SY is the diagonal. Measure angle KSY is equal to 90 minus 30 is equal to 60 degree. Triangle SKY is a 30, 60, 90 degree triangle. Measure angle Y is equal to 30 degree and side opposite to angle Y is SK 3.5 centimeters. SK is equal to 1 upon 2 SY. This is by 30, 60, 90 degree triangle theorem. Twice SK is equal to SY. Therefore, 2 into 3.5 is equal to SY. Therefore, SY is equal to 7 centimeters. Measure angle S is equal to 60 degree and KY is the side opposite to angle S. Therefore, KY is equal to square root 3 upon 2 SY, 30, 60, 90 degree triangle theorem. Therefore, KY is equal to square root 3 upon 2 into 7 is equal to 3.5 square root 3. Therefore, KY is equal to 3.5 square root 3 centimeters. What did we learn? Isosceles triangle theorem. If two sides of a triangle are congruent, the angles opposite to them are also congruent. 30, 60, 90 triangle theorem. If the acute angles of a right angled triangle are 30 degrees and 60 degrees, the side opposite to the angle of 30 degree is half of the hypotenuse and the side opposite to the angle of 60 degrees is root 3 by 2 times the hypotenuse. 45, 45, 90 triangle theorem. If the angles of a right angled triangle are 45 degree and 90 degree, each perpendicular side is 1 by root 2 times hypotenuse. Exercise. Observe the given figure. In triangle PET, PE is congruent to PT, angle PET is equal to x degree, angle EPT is equal to y degrees, and angle PTA is equal to 105 degrees. Find the values of x and y. Also find the measure of angle PTA. Observe the given figure. In triangle PQR, PR is equal to 10 centimeters, angle PRQ is equal to 30 degrees, PS perpendicular to QR and PS congruent QS. Then find out PS, QS and QR. State and prove the converse of isosceles triangle theorem. In triangle ABC, angle B is equal to 90 degrees, AC is equal to 6 centimeters and AB is equal to BC. Then find out AB and BC.